Hello students, let's start a new chapter, that is exercise 21a. Prove the following identities, trigonometrical identities. Okay, but before we proceed on solving the questions from this chapter, let us see the formula that will be helpful for us to solve the problems. Okay, now let us first see the formula and then only we will proceed. First, let us understand that this is a triangle. Okay, right angled triangle, right angled at this point. So if we talk about this angle, suppose this is angle theta, then at this case this portion will be base and this will become perpendicular, this will become hypotenuse. Okay, suppose this is triangle ABC. If we are talking about angle C, then base will become B, this BC will become base and AB will become perpendicular. AC is always the longest side, the hypotenuse. Okay, but if we turn the triangle and talk about this angle A, instead of talking about this angle, if we talk about angle A, suppose this is angle alpha. Okay, if we talk about this angle, then at this time the base will be AB, perpendicular will be BC. That means perpendicular and base can be interchanged simply by talking about the angle, by considering the angle, isn't it? If we talk about this angle, this side becomes base and this side becomes perpendicular. If we talk about this angle, then this side becomes perpendicular and this side becomes base. Whereas the hypotenuse always remains the fixed. It is the longest side of any triangle. Okay, not any triangle, right angle triangle. So let us start writing the formula that will be helpful. Number one is sine theta equal to perpendicular upon hypotenuse. Number two is cos theta equal to base upon hypotenuse. Number three is tan theta equal to perpendicular upon base. Number four, cot theta equal to base upon perpendicular. And number five, sec theta equals to hypotenuse upon base. And number six, cosec theta equals to hypotenuse upon perpendicular. Okay, sine theta equal to p by h, cos theta equal to b by h, tan theta p by p. We have a certain mnemonic to remember this formula. Some people have curly brown hair, turns permanently black, coming back people see him black, called him Pat. That's it. Some people have curly brown hair, turns permanently black, coming back people see him black, called him Pat. Okay, so this is the way, such mnemonic we use to remember this formula. So please take the screenshot. It will be very useful while solving the questions from this chapter. Okay, now the next one is tan theta equal to sine theta by, this is not C, sine theta by cos theta, and cot theta equal to cos theta upon sine theta. This is another formula 1 and 2. And another formula we have is sine square theta plus cos square theta equals to 1. Then obviously you can write sine square theta equals to 1 minus cos square theta, isn't it? So cos square theta equals to 1 minus sine square theta. This cos square theta, if you take to the right hand side, it becomes minus cos square theta. So sine square theta equals to plus cos square theta goes to the right hand side and becomes minus cos square theta. Okay, so similarly we have another formula, sec square theta minus tan square theta equals to 1. Needless to say, sec square theta equals to 1 plus tan square theta, isn't it? So tan square theta equals to sec square theta minus 1. If you take tan square theta to the right hand side and bring this one to the left hand side, sec square theta minus 1 becomes tan square theta. And number 5 is cosec square theta minus cot square theta equals to 1. Okay, this is cosec square theta minus cot square theta equals to 1. So cosec square theta equals to 1 plus cot square theta. So I hope you got this formula. Please take the screenshot of this. We need this while solving the problems. Okay, so let me continue now. So this is the first question from this exercise. We are asked to prove this is equal to this, isn't it? Sec a minus 1 upon sec a plus 1 equals to 1 minus cos a upon 1 plus cos a. So we are asked to prove this. Left hand side, LHS means left hand side. We have sec a minus 1 upon sec a plus 1, isn't it? This is in the left hand side. So we are asked to prove 1 minus cos a upon 1 plus cos a. Since, oh, I forgot to give that formula, isn't it? Sin theta, please copy this formula also. Sin theta equals to 1 upon cosec theta. Number 2, that means cosec theta equals to 1 upon sin theta, okay? Tan theta equals to 1 upon cot theta, and cot theta equals to 1 upon tan theta. Similarly, cos theta equals to 1 upon sec theta, and sec theta equals to 1 upon cos theta. Okay, please copy this question, formula. We need this here. Sec theta means if cos theta equals to 1 upon sec theta, then bring this sec theta here and cos theta down. Okay, sec theta equals to 1 upon this cos theta goes to the denominator, cos theta. So sec theta equals to 1 upon cos theta, isn't it? So instead of this sec a, you can write 1 upon cos a. Are you getting me? Sec a means 1 upon cos a, because sec theta equals to 1 upon cos theta. So sec a is 1 upon cos a. So minus 1 whole upon this sec a means 1 upon cos a. So plus 1. Now here we have 1 in the denominator of 1, isn't it? So let us take the LCM of cos a and 1. So the LCM will be cos a, isn't it? So 1 into 1, 1 minus cos a into 1, cos a. Are you getting me? Whole upon, here also we have 1 in the denominator of 1. So LCM of cos a and 1 is cos a, and 1 into 1 is 1 plus cos a into 1 is cos a. So this cos a and this cos a can be cancelled, because suppose if I write a by b upon c by d, a by b upon c by d, what happens is a by b into this d goes to the numerator and c comes down to the denominator, isn't it? D goes to the numerator and this c comes down to the denominator. So cos a goes to the numerator and this 1 plus cos a remains in the denominator. So that means that numerator cos a and this cos a can be cancelled. So let us cancel this cos a here. So now we have 1 minus cos a upon 1 plus cos a. 1 minus cos a, let me write clearly, 1 minus cos a upon 1 plus cos a. So this is right hand side equals to right hand side, hence proved. I hope you got me. So let us do the next question. Here we have 1 plus sin a upon 1 minus sin a equals to cosec a plus 1 upon cosec a minus 1. We are asked to prove this equals to this, isn't it? So we have seen the formula, since sin theta equals to 1 upon cosec theta. Cosec theta, okay? Sin theta equals to 1 upon cosec theta. This is the formula which we need here, okay? Left hand side equals to 1 plus sin a upon 1 minus sin a, isn't it? This is in the left hand side. We are going to use this and prove this, okay? So 1 plus sin a can be written as, sin theta can be written as 1 upon cosec theta, isn't it? So sin a can be written as 1 upon cosec a. This is the formula for sin theta. Sin theta equals to 1 upon cosec theta. So sin a equals to 1 upon cosec a whole upon 1 minus in the denominator, 1 minus this sin a can be written as 1 upon cosec a. Cosec a, isn't it? So this gives us, here we have 1, so let us take the LCM of 1 and cosec a. So LCM will be cosec a. cosec A. So cosec A into 1 cosec A plus 1 into 1 is 1 whole upon, here also we can assume 1 and take the LCM of 1 and cosec A. So the LCM will be cosec A, isn't it? This will be the LCM. So cosec A into 1 cosec A, because the LCM is cosec A. So minus 1 into 1 1. Now this cosec A and this cosec A can be cancelled. So in the numerator we have cosec A plus 1 cosec A plus 1. In the denominator we have cosec A minus 1 cosec A minus 1. So this is the right hand side, isn't it? Cosec A plus 1 upon cosec A minus 1. So this gives us right hand side, hence proved. Okay, this is proved. Now let us move to the third question. Okay, let us do question number 3. Okay, now in this case we need this formula: tan theta equal to sin theta upon cos theta, and cot theta equals to cos theta upon sin theta. This is the formula which we need here. Okay, so left hand side, in the left hand side we have 1 upon tan A plus cot A, isn't it? So tan A plus cot A. So we are going to use this and prove this. Okay, sin A into cos A. So this means 1 upon tan A means sin A upon cos A. Tan A means sin A upon cos A, isn't it? So plus cot A means cos A upon sin A, cos A upon sin A. Are you getting me? So we have 1 in the numerator, and let us take the LCM of cos A and sin A. So cos A and sin A remains in the denominator. So LCM of cos A and sin A is cos A into sin A. Okay, now cos A into sin A gives us cos A sin A. So that means sin A into sin A, sin square A, plus sin A into cos A gives us cos A sin A. That means cos A into cos A is cos square A, isn't it? So sin square theta plus cos square theta, since this is the formula, sin square theta plus cos square theta equals to 1. This is the formula which I gave you earlier, isn't it? Sin square theta plus cos square theta equals to 1. So instead of this sin square A plus cos square A, I can write 1. So 1 upon this sin square A plus cos square A is 1 upon cos A into sin A, cos A into sin A, isn't it? So let us multiply this. 1 into this goes up, cos A into sin A upon this 1 comes down in the denominator. That means 1 into this is cos A into sin A upon 1 is cos A into sin A, isn't it? So cos A dot sin A. So this is what we are asked to prove: cos A into sin A equals to right hand side, isn't it? So this is proved. Okay, now let us move to the next question. Okay, now let us do the next question. Question number 4. We are asked to prove tan A minus cot A equals to 1 minus 2 cos square A upon sin A cos A, isn't it? So let us use the left hand side and prove this one. Okay, so left hand side equals to tan A minus cot A, isn't it? So this tan A can be written as sin A upon cos A. So instead of this tan A, I write sin A upon cos A minus this cot A can be written as cos A upon sin A, cos A upon sin A, isn't it? So let us take the LCM of cos A and sin A. The LCM becomes cos A into sin A. Cos A into sin A, the LCM is cos A into sin A. Now cos A into sin A gives this. So sin A into sin A is sin square A minus cos A into cos A is cos square A. Okay, since the LCM is cos A into sin A, cos A sin A, so cos A into sin A gives this, so sin A into sin A is sin square A, and sin A into cos A gives this, so cos A into cos A is cos square A. This minus sign remains in the middle as it is. Okay, now we have sin square A minus cos square A, but we need 2 cos square A, we need cos square A in the numerator. So let us convert this sin square A to cos square A form. Since we know the formula, sin square theta plus cos square theta equals to 1, isn't it? So sin square theta can be written as 1 is already in the right hand side. Let us take this plus cos square theta becomes minus cos square theta in the right hand side, isn't it? So plus cos square theta when taken to the right hand side becomes minus cos square theta. That means sin square theta equals to 1 minus cos square theta. So instead of this sin square theta, I write cos square theta, okay, because I need cos square A, isn't it? So instead of this sin square A, I write 1 minus cos square A, okay. Instead of this sin square A, I write 1 minus cos square A. This sin square A is 1 minus cos square A minus this is cos square A, isn't it? This is cos square A. So in the denominator we have cos A into sin A, cos A into sin A. Okay, now 1 we write as it is. Now minus cos square A and minus cos square A, same thing, isn't it? Both are negative, so minus 2 cos square A. Minus A gives minus 2A, isn't it? Both are same and both are negative, so they gets added, but the sign will remain minus. Similarly, minus cos square A minus cos square A, same thing, and they gets added, but the sign will remain minus. So minus 2 cos square A upon cos A sin A, cos A dot sin A. So I think this is the number in the right hand side, isn't it? So 1 minus 2 cos square upon cos A into sin A into cos A and cos A into sin A, same thing, okay, because 2 into 3 is 6 and 3 into 2 is 6, so no need to bring the sin A here and cos A later, okay. So you can write in this form as well. So this is right hand side, hence proved. Now let us do the next question, question number 5. Okay, now let us do the next question, question number 5. We have sin to the power 4a minus cos to the power 4a in the left hand side, and we are asked to prove 2 sin square a minus 1 in the right hand side, isn't it? So let's start. In the left hand side we have sin to the power 4a minus cos to the power 4a, isn't it? Since you know that a to the power 4 can be written as a square whole square, so this gives us 2 to the 4, isn't it? 2 to the 4. A to the power 4 can be written as a square whole square, because a to the power m whole to the power n equals to a to the power mn. This rule is from the indices, isn't it? So instead of this sin to the power 4a, what I write is sin square a whole square. So 2 to the 4, isn't it? Sin square whole square. So sin to the power 4 minus cos to the power 4a can be written as cos square a whole square. Are you getting me? Cos square a whole square means 2 to the 4. Now we have, let us consider this as a and this as b. So a square minus b square. So we know the formula, a square minus b square equals to a plus b whole a minus b, isn't it? So a square minus b square equals to a plus b whole into a minus b. So sorry this is a and this is b. So a square minus b square equals to a plus b, isn't it? This is a plus b, again a minus b, a plus b, a minus b. A square minus b square equals to a plus b, a minus b, isn't it? So this sin square a plus cos square a is sin square theta plus cos square theta, isn't it? So this equals to 1. So instead of this sin square a plus cos square a, I can write 1. So this bracket means into, isn't it? Into bracket means into, okay, into. We need sin square a, isn't it? So let's convert this cos square a into sin square form. Okay, let us keep this sin square a as it is, sin square a minus, so within the bracket cos square a means, so from here cos square theta means, let us keep this one here itself. So let us take this plus sin square theta to the right hand side. It becomes minus sin square theta, isn't it? This plus sin square theta, if you take to the right hand side, becomes minus sin square theta. So this cos square theta, where is cos square theta? Oh, this cos square a, this cos square a becomes 1 minus sin square a. This cos square a is 1 minus sin square a. Okay, this sin square a plus cos square a is 1, and this sin square a is this sin square a is this, minus this cos square a minus means 1 minus sin square a. Okay, so 1 into sin square a is sin square a, isn't it? So minus into plus is minus. There is no sign in front of 1, means we should know that there is plus. So minus into plus is minus. Again, minus into minus is plus, minus into minus is plus. So sin square a, isn't it? So this plus sin square a and plus sin square a, there is no sign, means this is plus sin square a, isn't it? So plus sin square a and plus sin square a is 2 sin square a, 2 sin square a. Are you getting me? 1x plus another x becomes 2x, isn't it? So this is minus 1. So I think this is the right option in the right hand side, RHS, hence proved. Okay, I hope you got this. Thank you so much for watching this video. Stay tuned, I'll be uploading more content like this, so please subscribe the channel, okay, and do not forget to hit the like button.